YouTube, it's Faye, and for today's video, I'm doing the follow-up on the intake manifold build, my forward-facing intake manifold. So we had one last little piece to weld where I left you last. If you missed that video, click right here on the link above and you will see that video to get you caught up. But today, Danny's gonna start out by welding probably the most challenging part of this manifold, which is not challenging to him, but would be challenging to me. And that is a little bracket that I made. And then for the rest of this video, I have no idea what it's gonna be because I am in the future and we're just gonna see what's gonna happen. So, hey Danny!
Here we are.
So we have, of course, this intake manifold. You guys remember this from my last video. We got the bungs welded. We've got this drift motion custom piece for my idle air control valve. And now we've got that little bracket that I made in the last video to hold my throttle cable.
Yes.
One thing we sort of mentioned in the last video is look how beefy. This is a very thick manifold, well-made piece.
Yes.
For the most part, they just kind of forgot some stuff, but we don't fault them for that.
It's a good starting point. Very good starting point.
Great starting point.
Real good. And it welded really nice. So whatever they're casting it with, actually, didn't have a lot of junk in it. So it welded really nice. It looks real pretty. It's really easy to weld on. So now the difficulty comes in the thick manifold, which is awesome. It's not a sheet metal manifold, but then we have a thin piece. By the time we start heating it enough to melt this aluminum, we've burnt this aluminum.
Exactly.
So we're going to do a little bit of preheating.
The marks that we made already faded off a little bit, didn't they?
When you want aluminum, you want to make sure that you brush it with a stainless brush. Don't use any other kind of brush, hairbrush or steel wool, whatever. But it's a stainless brush. Well, if I brush this to prep it, there's our lines.
Yeah, it's gone.
So what we're going to do is I'm going to go and take and just scribe me a line right where this is going to go. That way, I can clean this area, I can prep it, I can brush it. Also, we don't want the black ink, getting in our weld.
Yeah, yeah.
And so by scribing a line, now it can go in the oven, it can come out, we can put it on, easy cheese, and I don't have to worry about putting this backwards or missing it. So,
now you said put it in the oven.
Yes.
Oh, we're gonna bake it.
Yeah, we're gonna put it in the oven right behind us.
All those people that tell me to get back to the kitchen, okay? We literally have an oven right here, people. I am already where I'm supposed to be, okay? And so is Danny. Danny uses the oven more than I do.
Yes.
So, okay, so
yes.
Sorry, I cut you off. You were saying we're getting this up to temperature.
I like that, yeah. So we're gonna go ahead and put it in the oven and bring it up to temperature, almost to 300 degrees, 250, 300, just so that when we start welding, we're not just using the TIG welder to try to heat this up, because then I'm going to crank down on it. Here it was okay. Why was here okay? Look at the thick machine billet piece and the thick manifold.
Yep.
So we had two pieces that were pretty close to the same thickness. I could crank down on it and put as much heat as I wanted, and I wasn't going to burn one away from the other.
Exactly.
But here, by the time we did this would be burnt. We wouldn't have this anymore. Or it wouldn't look as well because it would just be all melted.
Now, Danny, now you said 300 degrees, that's hotter than this is going to get on the car. Mm-hmm. So am I then going to have to worry about anything else warping? Should I recheck everything at the end?
Smart move to always to recheck it. The beauty of putting it in an oven to preheat it is that we don't have as much distortion, if hardly any. When I weld a cylinder head or something that with a camshaft in it, any little bit of distortion there would actually be bad.
Yeah.
And that's why we would most definitely do a cylinder head in the oven. We wouldn't want to do a cylinder head cold. By the time you get to one spot, that you get so hot right there to get it to weld, the head just starts to bow because it's still cold everywhere else. And aluminum extracts heat. It dissipates heat so well that's another thing that you're fighting, is the heat that you're putting into it is being dissipated just that fast. So, that's why we're going to preheat it, just to kind of give us a little insight. Anybody welding something really thick, preheat it. You could use a torch.
I was gonna ask, should I go looking for used ovens now to put in my shop?
An oven ain't a bad thing to have. An old kitchen oven. You can do powder coating when you're pressing bearings. A lot of times, you can just heat the bearing. I'm talking about less than 200 degrees, and it will slide right on. So an oven really, once you start getting into it, it's very useful for a lot of things. We use an oven to heat the head up to install seats. When you're going to do a seat or a guide in aluminum, could you drive it in? A lot of people do drive it in told, the problem is there's so much press fit, it galls the aluminum.
Oh.
And you're actually just pulling aluminum with it.
Okay.
But by expanding it, the seat can just go right in. Once it cools down, you got the right press fit, and you're not going to drop the seat. So oven is really, when you're messing with aluminum, you almost pretty much want to use an oven.
Well, I'll be darned.
Then when we weld it, we have penetration because we've already put it in there.
Yeah, exactly.
Yeah,
we know it's sitting in there. It's sitting pretty.
Welding aluminum or heliarc welding is any contaminants at all just get sucked into the weld, and then you get porosity and stuff. So stainless will clean it but not add contaminants. If you use a metal brush with steel or anything else, you're brushing and it's looking pretty, and then you're adding steel into the aluminum and it contaminates it, and you're just not going to weld with a darn. And a lot of times it's just the prep, and people don't realize what am I doing wrong, and you're just adding so many contaminants to it. You might as well just left it alone. So that's why it's stainless, because it can clean but not add anything. You could use any kind of oven, but this being an oven specifically for head straightening, you can see this thick plate that's perfectly machine flat, and you can put the cylinder head here and run bolts to straighten the head. We could, bolt something down to it to keep it flat. We're not going to get it that hot, and we're not going to, this thing is so thick, we're just going to preheat it. But that's what this is for. This is actually for straightening cylinder heads.
Okay, so while we are waiting for the manifold to bake, we're moving on to other things. Aren't we, Danny?
Yes, we are.
Here we have this throttle body that I got on eBay. It actually came with the manifold that I bought previously, that one JZ manifold. And then I have this extremely expensive, overpriced stanchion clamp that I never thought I would spend that much money on a clamp, but I'm only buying one of these people.
It's a pretty killer clamp. So it allows it to flex.
Yep.
With O-rings, but these nice cool elbows as well. And then here's our billet piece. We're going to TIG weld this around here.
Yep.
And that's one part of it.
Uh-huh.
The next part is the part that goes on the other side.
Exactly.
Which is this, which we're going to TIG weld onto there. What did you have to do? We had to get rid of the anodizing.
Exactly.
Yeah, remember when you're welding, you can't have any kind of impurities at all. Anodizing goes in. The reason anodizing is so awesome as opposed to paint or stuff, it actually embeds itself in the pores.
Oh,
sometimes,
okay.
Depending on the anodizing and how much the anodizing and what quality, as I start to weld, we may bring up all bunch of crud. If we do, we're going to stop and we're going to brush and we're going to keep cleaning. What Faye did was she got rid of all of the anodizing. Don't try to weld on top of the anodizing. It's hard enough to weld aluminum clean, and if you add so much, like a non-stainless brush or dirty stuff, it makes it a lot worse. And that's why a lot of people don't even want to weld aluminum, because they just have so much struggles. I like the ones with the wood, because when I weld a hot cylinder head, the ones with the plastic handle melt, and then you contaminate your weld.
Oh.
So get you one with the wooden handles. The main advice on aluminum: clean, clean, clean. You can't be too clean.
Oh, look at this setup.
Just want something to hold it on there. I don't have a lot of pressure on it. When you weld, it's going to want to lift the other side. Once you put heat right here, as it starts to cool down, it'll start to shrink up, and then it'll just start lifting up this other side. We got all the electronics off of it. That's another thing, is don't TIG weld. Especially TIG welding is high frequency, so you don't want any electronics on it. You could take out a part. Other kind of welding, it might not be high frequency welding, but TIG welding is high frequency, so it could actually damage it, but it's gone, so we're good to go.
Alrighty, what we got here, Danny? We got some bad news.
It's not really bad. I expected it. We kind of expected it, and we're going to go with the flow. But here's the deal. It does have a lot of impurities. You can see all of the crud that's coming out. We've already glass beaded it. We've stainless brushed it 2 times already.
Yeah.
And it's still bringing up crud.
Yep.
If you look at the top piece, how nice and white it is.
Yeah.
That's what we're looking for.
Yep.
Beautiful, clean. It's not pulling anything out.
Yep.
And it's already etched it. So it's already etched it, and there's nothing that they can pull out. Here, like I said, it came out. I brushed it, did it again. So we need to go ahead and get rid of another layer so that we can get to some good aluminum.
Okay.
If not, like I said, we could weld it. It just wouldn't look very nice.
Got it.
It would have a bunch of little pinholes everywhere, and we just don't really want that.
Oh my God, Danny, that's so brilliant, because then it's gonna be, see, I was thinking I was just gonna hand do it on the grinder, but instead,
look at this.
This is gonna be machine. Oh my God. Why do it by hand when you can do it by lathe?
Yes, we're done. Dang. I'm gonna just put a little bit of JB Weld on it.
This is now a press fit. Look at the inside here. Oh my God. Oh my God.
We literally could just press it on and then that's just gonna help. It's gonna be neat. It's gonna make it easier alignment. There we go. So, and it's gonna help with we didn't get crazy for no reason, but in welding
Sometimes we do.
Yeah. It did bring up some impurities. So,
Yes.
so we wanted to just take the outer layer off. You know, we took some aluminum off so we can get past the outer layer. In doing that, it's kind of like, it just was talking to us. It's kind of like, well, why don't we just put a little lip on the inside?
You just gotta be like water and go with the flow,
Yeah,
man. We're just going with the flow, man.
And so,
oh my God, look at that. I mean.
so it's there. We took a frustrating moment. We went to go weld, and crud came out, brushed it, crud came out again, and took something that was, you know, and turned
bummer.
it into something that's so freaking cool.
Yes!
So,
Oh, that is beautifully clean.
it was worth the effort. They can see how that
absolutely was.
nice and white, nice and clean, no impurities.
Wow!
Once we brush it or clean it with a little bit of that's right, and it'll be shiny again.
Now that we have one of the flanges attached to the throttle body, it's time to prep this 90-degree tube for the other flange. Oh my God. Look at that, you guys. Danny is the man!
Let's see if it's up to temperature. It's going to extract all the heat, so we want to see. It's not, you know, super hot, but it is.
292!
And the heating elements are in the back. You see how hot 600 degrees.
Oh, wow.
Yeah.
Oh,
so,
my gosh.
So we're good. Now when we go to weld, we're not going to be extracting all our heat to try to heat this part up.
Exactly.
Yes. So it's going to help us to kind of act like both pieces of metal are the same thickness. So you just gave it a little heads up. We're going to give you the tips on the tips. The main thing is you see all the different tungstens and how thick the tungstens are. General rule of thumb, how thick are you going to weld? Pick the tungsten that's close to the thickness of what you're going to weld. I'm going to pick the one that's pretty darn close.
Ooh, our pie is done.
Yes. And the same with the rod.
Yep.
Pick one about the same size tungsten piece. This piece that Faye used, this alloy, is once you start getting it first, you just want aluminum. So you don't know anything about alloys or anything, and you don't have to know much about it, except that the higher the alloy, the stronger the aluminum is going to be. So this alloy, this metal, even though it says thin aluminum, you can't even bend it.
Yeah.
It's very difficult to bend. You got to put a V in it to bend it, or it's just real difficult. Soft.
And then when I did go to bend it, it broke.
Yeah. Because it's because the alloy. Exactly. So it doesn't like to really to bend. It's real brittle. It's a lot of the higher the tensile strength, the kind of more brittle it gets in bending. Soft aluminum will bend real easy. What is the beauty of that? There's two beauties of that. A, this is a throttle. You're going to be pulling on this like crazy.
Yes.
Look at these little fingers. You may look like, oh my God, you're asking for trouble. No, we're not. You cannot even bend this.
Yup.
And that actually helped the two-part. We preheated this. It's still warm. We didn't burn it up by no means.
Yeah.
But it took the heat really well.
Yes.
Because it's a good quality piece of aluminum.
Yeah.
So soft aluminum, we would have it wouldn't have looked like this. You would have been struggling. You're going to burn this piece off by the time you weld it. So,
and now, what's a tip for somebody if they're going out to just get a piece of aluminum that they hope to make a bracket like that and have some welding? How would they be able to recognize an alloy versus a soft?
Bite it. You kind of silly thing, and I know aluminum oxides are probably bad. It's probably bad in a thing, but bite.
Like seriously, you actually mean frickin' put your teeth on it?
Yes. We could try, like when you go get welding rod. 40-43 is what you're going to get.
Yeah?
You can bite and leave an indentation in there.
Okay.
Now get 50-56. Good luck. So really, I know it sounds kind of silly. Take something and either scratch it.
Right.
Or once you start knowing more, you'll know, oh, that scratch is real easy. And all of the cable is tracking perfectly flat.
It is.
I mean,
it's perfect.
This is cool, yeah. So it can't burst off, and it allows it to still flex without putting, stress on the intercooler or anything else.
All right, so the next step is this manifold is going off for powder coating. Not all of it though, just part of it. And then I'm actually gonna do some art on this manifold. So Danny, I think we are well on our way to getting this to be easily a 100-hour manifold. So this is great. Thank you so much for watching. I hope that you enjoyed this video, part 2 of my forward-facing intake manifold fabrication. And huge thanks to Danny for those beautiful welds and for his help with all this fabrication. And if you have not checked out his channel yet, or if you're new here and it's like, who the heck is Danny? I will link his channel in the description below. He has a lot of videos specifically on welding for automotive as well, not just for stuff like this where there's like, oh, this new, clean, perfectly easy to weld aluminum parts, but
like aluminum timing cover or something that came off of an existing car. It's a totally different, way to weld, but you can do it. Go watch the videos.
Absolutely. I'll link it right above right here.
And I hope all this fabrication really kind of just got some people empowered. Maybe somebody's going to go out there and buy a TIG welder and go, hey, you know what? I can make anything with a TIG welder. It's almost like the lathe or the Bridgeport.
Exactly.
Your endless amount is just your brain, what you can think of. So if anything else, it looked like fun. It was fun. Yeah. It really was. So.
Or maybe you're someone like me that is not a very good TIG welder, but you want to create your own forward-facing intake manifold or any automotive part. You also, now you know how to pick out good aluminum pieces that will be easy for a welder to weld. Now you have seen some of the behind the scenes of the fabrication. So I literally made a $400 manifold into something, awesome, like perfect for my application. So much easier to cut and modify a $400 manifold than a $1,200 manifold. So you too can go on eBay and purchase a Chinese or a Taiwanese manifold.
It's a good starting point.
Your own.
It's a good starting point. You might not have to. We cut the flange off of it. It wasn't the right flange, but we started out with 80% of what was there.
Yep.
And sometimes that's, even it might not fit your vehicle. It may be you're working on an Isuzu or something, but a Honda manifold is pretty close.
Right.
Start off with that one. Chop off the flange, and it's not a bad way to go. Especially when the hours that you're going to have fabbing, starting off with something that gets you pretty close. It's not a bad way to do it. Especially now, like I said, eBay, go buy a manifold.
Yeah, and this makes sense for the 7M. Now there's a lot of aftermarket options for the 1JZ and the 2JZ, but not for the 7M. So I remember like our first sort of go around, we were talking about, I actually purchased an even cheaper 1JZ manifold just to have that shape, and then I was like, well, I'll just weld the runners.
The runners,
what am I trying to say?
And actually cut it and spend a lot of time even doing it.
Yeah.
And started fabbing on it.
And I think I'm actually going to finish that one up at some point just for fun now that I've got this one. But that one was just such a good deal. It came along. So anyway, thank you so much for watching. I really hope that you enjoyed this video. Check out the other videos that I have in this series, the Super Saga series, and check out Danny's channel. And we will see you in our next video. Thanks, guys. Bye. Scarlett. Hi, Luna. Hi, Luna.